Hi everyone, welcome to my YouTube channel TechDataEngineer. So in this video we will see the concept regarding LLM. So everyone nowadays everyone using GenAI in their project. So if you are a tech engineer and you are not from the AI expert system, like you are not a data scientist or not you are not a machine learning engineer or not a GenAI engineer, but still you are using the LLM as a you can say API or LLM in your project. So you should be aware like what is LLM, how it is work, what is the basic functionality of LLM, what are the things we need to understand before knowing LLM. Okay, so that you can make or you can integrate LLM in your project in very good way. Okay, so this is only the functional things I'll explain about LLM, how transformer work, what are the network, what are the techniques which is used in LLM. Okay, and then we'll see certain challenges also, and I'll explain certain there are certain mathematical model also which will be basically the main core part of this LLM, but that will explain in later video. So this video covers only what is LLM, how it is getting trained, what is the functionality of LLM, and how we can scale LLM and all, so that we can see each and everything in this video. Okay. So start with the LLM. So what is LLM? So LLM is nothing but it's like a advanced AI system that is basically based on the deep learning technology. Okay, that is basically based on the deep learning technology, especially if we'll talk about the deep learning, so that is basically based on the transformer logic. Okay, so why LLM is built? So earlier there was a legacy system that was the NLP, which we building the chatbot or any natural language based applications. Okay, so now now the concept, so LLM came uh, uh, to design and process and generate the text that resembles the human language. Okay, so now we have seen applications like ChatGPT, Google, Gemini, Anthropic, Cloud. So everything is there. That are the examples of LLM. Okay. So what LLM basically do? It do the questions answering. It will do the sentiment analysis. It will do the image captioning. It will do the object recognition. So whenever we pass the voice, text, and image, anything to the LLM and the prompt, then based on our prompt, it will give the different. I can say based on our things. If you are asking a question, it will give the answer. If you wanted to do some analysis, it will do the analysis. If you wanted to change some image, it will change the image. It will do the object recognition. So everything will be doable by this GenAI LLM. Okay. So now as we see the term LLM, LLM has three things. Okay. So one is the large, one is the language, one is the model. So what large indicates here? So large indicates here because that is the trained on the billion or trillions of parameter. Okay. So uh, this whatever this mathematical model we have, whatever this deep learning model we have, that is trained on the billion or trillions of parameter. That's why it is called large. Language is specify here that is basically specialized for natural language processing. Okay, like human language, task understanding, question answering, summarization, this token understanding, code generations. So that's why it is called language. Then model. Model is nothing but it's like a mathematical system that map input to output. Input is nothing but in case of LLM, the input is prompt, whatever we are giving, like write a summary of India about in 500 words something. This is the called prompt. It will give the output as a response. Okay. So LLM has three things: large, language, and model. Large is billions of parameter or trillions of parameter where it is getting trained, and language is the natural language, and model is the mathematical things. Okay, basically the transformation. Okay. Now the next things how LLM basically work. Okay, how does LLM work? So LLM have the concepts of so the basic, I can say the basic and the main work of LLM to, you can say, find out the next token. Okay, so the token prediction was the first token prediction is the main work of the LLM. Okay, so what is token, how we are achieving that things we will see in the upcoming slide. But so what it do basically, it sees a sequence of token. Okay, and then it predict the most likely next token based on their weight value, and then it repeat and generate the coherent sentence, paragraph, or even code also. So based on next token finding, it will complete the paragraph, sentiment, and your questions answer. Okay, now let us see with the example. Suppose we have the example like the capital of France is, then LLM predict it's a Paris. Okay, so why Paris? Because Paris have the high, you can say, weightage. So that's why he predicted the Paris. So how it is predicting that we will see in the upcoming video. But so let us understand with the tokenization. So what is tokenizations? How it is achieving, how it is finding the next token based on the weight value. So suppose if I am writing here what is AI, okay? So the in this case of LLMs, model does not see the word directly. Okay, what it will do, it will split the text into different tokens. Okay, that is called that is small chunks of what that is called token. So here, what is AI? What is the token? The token ID is 1, 2, 3, 4. Is a token. AI is a token. Okay. So each token is then converted into vector called embedding, a list of number that represent a meaning. Suppose what is converted to 1, 2, 3, 4, is in converted to 5, 6, 7, AI in converted to 8, 9, 0. So whatever the prompt we are giving to AI, what it does, it converted to the vector. Okay, it converted to the embedding form. Okay, then what is embedding basically here? So each token embedding is passed into a transformer neural network. We will understand the transformer also in the better way. How transformation, what was the disadvantage of RNN and CNN, why transformation came, what is the parallel training, why transformation was more successful than the old system. We will see later. But here we, at least for the LLM purpose, we will see what is embedding here. So embedding is nothing but it is like a each token embedded is passed into a transformer neural network. Okay, and then transformer has many layer like GPT-3. So as we know, GPT-3 have 96 layer, GPT-4 have more. I mean, if upcoming GPT have many more layers. Okay, so more layers means more training. So at each layer, the model refine its understanding of like meaning of token, how they relate to each other. Okay, so at each layer, each so we have the input layer, we have the output layer, we have the hidden layer in case of transformation. So if I'll explain the transformation, I'll explain the concept also how training is done at the different layer. So but for now we can understand like each layer. Okay, the model refines it understanding of meaning of token, how they can relate to each other. Okay, so they are basically embedding work. Okay, then we will see the attention mechanism. What is attention mechanism in case of LLM? Okay, so imagine you are reading the cat sat on the, then what is the next word? How LLM predicts? That basically came from the attention mechanism. Okay, so to predict the next word, the model must pay attention to cat and sat. So if you wanted to predict the next word, so in upcoming in your previous word you have to pay more attention. So that is called self attention. So self attention leads the model assign different weight to token. So here they have the low attention, cat have the more attention, sat have the more attention. So the cat sat have more attention, then it has coming to the next word like mat. So this way model no mat is likely then other words like banana or anything. So the cat sat on the instead of banana we can finding the mat because of the self attention, because of the their weightage. Okay, and then how our next token is getting predicted. So that the LLM is trained with a very Simple rule, okay? So given the previous token, predict the next token. This is the main mechanism of our LLM. Given the previous token, predict the next token. So how the next token is getting predicted? Who have the more probability? Suppose the cat sat on the mat. So how mat is getting predicted? Because model prediction probability is mat is 80%. Different word like floor or banana is 0.1 to 15%. So that we will see the all the mathematical and probabilities things in technical videos, like where I'll explain the functions, mathematical functions, and how basically this attention mechanism and weight function will work. That explain there. But at least for now, we should know that so the main the main rule of LLM is to given the previous token, we need to find out the next token, predict the next token, and how the next token is getting predicted based on their model predict probabilities and their weightage value. So then the model picks like mat with a high probability. So this repeat this again and again until a full response is generated. So whenever we are giving the responses, when we are giving the prompt, it will generate the complete responses until or unless the full response is getting completed. Now we will see the different training mechanism also. Not only the probabilities, model predict probabilities, but we can see different training models also. At least we can see the functional things. Okay, how this way the LLM works. So now the next thing is the context window. So what is context window? This is basically for memory during the conversations. Okay, the model doesn't remember forever. So if you talk about the LLM like GPT-4, that can handle 128,000 tokens only. Okay, so at a time it can only see n tokens at once. Okay, so GPT-4 can see 128,000 tokens and all. Old tokens outside that window are forgotten. So they can relate to this much of tokens only. So if we have the more token window, our system will take much memory, much power, but it will give the much accurate result also. Okay, if our context window is small, it will not give the much accurate result. Okay. Then now coming to the training process, how it learned. So because that is the trend on the huge data sets, okay, like books, website, code, Wikipedia, web crawler, and everything. Billions of example of text, like model learn patterns of language. It does so the main thing is it does not memorize everything but generalize the pattern, okay, that uses the gradient descent to adjust the billions of parameter until predicts the accurate. So we will see what is gradient descent methods and all. So it basically the training process is like that. Then how fine tuning and alignment work. So fine tuning basically after pre-training LLM works on the instruction training, like follow human instruction better. If you are giving instructions to the LLM that follow, then reinforcement learning and human feedback that we will see later upcoming slides. Then what is DPO, direct performance optimizations? Okay, so these are the things which comes for this one fine tuning and alignment. Okay, now coming to inference. So inference is something, but when you type a prompt, so what it does basically, so whenever you type a prompt, it the model tokenize your text. Okay, so suppose I'm writing a write something about write write 500 words about India. Suppose I'm writing like that. Okay, so what it will do, the model will first tokenize your text. Okay, it will tokenize like write about India in 500 words. It will tokenize that. Then run it through the transformation layer. It will go through the input layer, hidden layer, then output layer. Then it will use the attention to predict self-attention mechanism. Then it will repeat until it generates the full answer. Okay, so that's why this is the inference mechanism for our LLM. So uh, so that's why it's look like typing the model word by word. Okay. So after this much, we now we can see what can LLM do. So we all already know that LLM can it's like a general purpose thing. So it will do the question answers. It, Okay, it will do the question answer, uh, like write text, email, blog, code, report, translate between language, different language, summarize long document. It will generate the artifact, generate conversation, generate code. So if we have the Power AI agent, it will generate, like it will interact with the LLM plus tool plus API also. Okay, we have examples like GPT-3, 4, 5. We have Anthropic, we have the cloud. Google DeepMind have the Gemini. Meta have the Llama, and then other company have the other LLMs also. Now the questions come to why LLM are more powerful. Okay, why they are more powerful? More the reason behind it, that they are trained on the more parameters. So scale is one of the more factor. They are trained on the more parameters, so obviously it will give the accurate result. They have the more training data, more parameter means better generalization. Training data is massive, so architecture is basically they are working on the parallel training. So transformations with attention mechanism lets the model understand relation across the word for long passes. So these are the techniques. That's why these LLMs are more powerful. Adaptability can be fine-tuned for a specific domain. So it is pre-trained, and then it is trained with the specific domain also. Okay. So that is called fine-tune. So law, medical, finance, coding, so different way also that is fine-tuned. So it has adaptability also. The now question comes to how they are different from the traditional AI. So old NLP system have the rule-based system, like we are giving the rule explicitly, rule, grammar, small database. But LLM does not explicit work on the rule. Okay, they learn the statistical pattern. They find out the next token based on the probabilities, and then they can find out the from the huge data set. They scale up more data. We can give them more parameter to train. That's why it's called the beta. Then get the better performance. Now we can see the concept of core of LLM. Okay, that is called transformation basically. So uh, trans in transformer we will see certain concept like what is called self attention. Okay, so what is self attention in case of transformer? So transformers, so suppose imagine you are reading a sentence like the cat sat on mat. So to understand mat you need to remember cat and sat, right? So self attention is a mechanism that let every word look at the other word. So if we are finding out the mat, then we need to find out the weightage of cat and sat. So in this sentence and decide which one matter most. Okay, so that is the self mechanism. So each token build a context aware meaning, not just the direct meaning. So here, so what is self attention basically? So self attention help the model to understand the relationship between words. Okay, like who did what, where, when, that is called self attention. Then now coming the multi-head attention. So what is attention? So instead of looking at the sentence one way, the model look as it is from the multiple angles. Okay, so that is called multi-headed attention. So one head might focus on the grammar, subjective, another focus on the who is the actor, other focus on the long distance, like it's a different thing. So another focus might be the long distance dependency between the token. So that's why multi-headed attention is also required. So that give the model a richer and multi-perspective understanding of different contexts. So that's why it is required. That is the core of LLM. Now the third thing is positional encoding. So what is positional encoding? Suppose if you shuffle the word like big bite man or man bites dog. Okay, sorry, dog bites man or man bites dog. So so they have the different meaning. Okay, so meaning changes, but attention by itself does not know the order. Okay, so what we have to do? So that's why positional encoding is required. So positional encoding, what it will do? It will inject the information about positions of each token. So that's why positions is required. So that ensure the model know the sequence of order and word position, so that the meaning should change. Okay, so we there it means that they are asking the different context. Now next thing is encoder decoder and encoder decoder mechanism. Okay, so that basically, so if we have a BERT, so BERT is basically works with encoder only. Okay, so read text at all and then used to understand the task. So what is decoder? Basically encoder here. So encoder, the mechanism is it will read text all at once. Okay, and then it will based on that, and it will give used for understanding the task. Basically it is come from the classification or search. And if you talk about the GPT have the decoder mechanism. So it generate text step by step used for chatbot, code writing or styling and everything. Okay, that basically work on that. And if we are talking about the encoder decoder, it's like old transformation. So read input with encoder, write output with the decoder, used to translation or summaries, something like that they used to work earlier. So that basically teaches the modern language fluently and this one and knowledgeable purpose. Now, the next concept is training object and predicting the next token. Okay, so LLM what it will do? LLM learns with one simple game, guess the next word. So this is the main concept. As we have already discussed, this is the main concept, like guess the next word. Okay, so that teaches the modern language fluently and knowledge. Okay. So what is the core of LLM? Input text, self-attention mechanism. So what input text it will do broken into tokens. If you're giving the prompt that is input text, what is the self-attention? The each token looks at other to build context. Then multi-head attention. So multiple view of relationship between the token. Positional encoding ensure they have the different meaning if word is order is getting changed. So ensure word order matters, then feed forward layers, process enrich meaning, then stack many layers like deeper understanding. The training objective predict the next token until it's fluent. Okay, that is the main concept, core concept of LLM. Now, if you talk about the LLM training and scaling concepts, okay, so LLM training and scaling concept. One is the parameter. So, LLM logic. So basically, so why what is parameter here? So parameter is the weight of the model. So LLM language. So basically, the LLM knowledge is stored in the parameters like billion or trillions of number. Okay, so knowledge is basically on the parameter itself. So these parameters are like knobs. Okay, that the training process adjusts to capture the pattern of language and all. Okay, so suppose like we have GPT-3 have 175 billion parameter, GPT-5 have much larger than that. So why parameters important for LLM? So if we have more parameters like more capacity to learn the nuance, okay. So if we have more parameter, more capacity to learn nuance. But also that is required. So if we have more parameters that require more computational power, more memory, more timings also. So what is the functions for parameter here? So parameter define what the model know and how it process the text. Okay. Now the next concept in case of LLM is pre-training versus fine-tuning. So what is pre-training? So pre-training is like trained on the massive amount of data, generic data like internet, textbook, Wikipedia and everything. So what is the objective of that? Objective to predict the next word. Okay. But what is called fine tuning here? So fine tuning is like if model is already printed, but that is trained with a smaller task, a specific data set, okay, a subset of data. Suppose there is like there is a LLM and we are training only on the medical data. In case of medical text, medical concept, so that will give the good question related to medical. So that is called fine tuning. So fine tuning is always getting trained on the uh, like a specific set of data, domain specific. So pre-trained models is a generic brain, while tuning makes it specialized. Okay, so pre-trained, and that is the difference between pre-training and fine-tuning also. Now the next concept is the transfer learning. So what is transfer learning here? So transfer learning, the basic idea is that do not start from the scratch every time. So we don't need LLM to start from the scratch. Instead of what it will do, it will take a pre-trained model, it's like already known general language, and transfer it to the new task or domain. Okay, so suppose we have example like a pre-trained GPT, and then we can do the fine tune on the legal document. Now it's a legal AI. So that is the like advantage of transfer learning. So transfer learning, it will know we don't need to learn from the scratch. Okay, that reuse the existing knowledge to adapt faster to newer tasks. So that we are doing in case of agentic AI also. We are training only on the specific thing, and then we are making certain our LLM to work only on that particular domain. Okay, that is called transfer learning or fine tuning. The next concept is instruction tuning. So what is instruction tuning here? So that instruction tuning is like even after pre-training, like LLM may answers like, suppose I'm asking like how to make a tea, okay? So tea is beverage made of leaves, something like that. It will give the answer and also. But instructions training, what it will, we have to get the answer. Like train the model on the data set only for instruction responses. If I'm asking how to make tea, then they should give the something like only give like give the instructions like boil water, then add tea leaves, then add milk, then add sugar, something like that. Okay, so for giving the instructions, we are using the instructions tuning also. Okay, to align and to give the instructions like a human things. Then next concept is RLHF, reinforcement learning and human feedback. So why this is important? Even after instructions training, model can too short or too unsafe also sometimes. Okay, so what is the RLHF process here? So RLHF means reinforcement learning with human feed. What is this process basically? That collect multiple output from the model for a prompt. Okay, and then it will human rank them like good or bad, and then based on that it will basically train on the reward model to predict the ranking. Okay, so human have the good or bad feedback. Based on that, it will learn and it will give the, it will based on the enforcement reinforcement learning, it will basically makes model more helpful, safe, and aligned to the human preferences. Okay, so there are, if I am giving, right, asking some, if giving some prompt, so LLM sometimes giving some thing, some answer which is not acceptable by the human, that is not safe or non-aligned to human preferences. So in that case, human is ignoring that and taking the other one. So that case, our LLM is learning from that learning from human feedback. Okay, so that's why it is required. Suppose if I'm asking LLM, tell me a joke, it is giving some joke that is not that is sometimes offensive also, so that we are not understanding. So always if we are giving the good so good output, what should be the good output here? It should be always be the either funny or safe joke. Okay, so that RLHF teaches LLM here that, so that makes the model helpful, safe, and aligned to the human preferences. Now the next concept is DPO, direct preferences optimization. So what is DPO here? So it's basically a newer alternative to RLHF. Okay. So reinforcement learning with human feedback. So that is the newer alternative of that. Instead of training a separate reward model, RLDPO directly optimize a LLM with the good answers overall bad and over the bad one. Okay, so it will obviously it will give the model to more faster, efficient way to align model to the human preferences. So by DPU technique, it will give the simpler, more stable, and less resource hungry also. Okay. So basically, it will not, it will skip the reward thing. It will just adjust the weight directly based on the preference and it will give the correct output. Okay. So these are the things which we need to understand if we are understanding the LLM. So we know understand how. So as a tech engineer, we know how to use LLM and all, but we should understand also how LLM basically works. If you wanted to understand more about that, we need to understand the what is the supervised learning, what is the self learning, what is transfer learning, how transformation work, how what are the hidden layer on that, what is neural network, how parallel training can happen and all. So this all thing we need to understand so that you if any answers came, you can create your AI systems also. Okay. So these are the brief about that LLM and all. Okay, so next video we will talk about the transformations, what are the how transformations work and all. So that we will see in the upcoming video. So everything related to AI, LLM, Gen AI or normal generic AI also I will explain in that video. Okay, thank you. Thanks for watching.